Lambda expression, a curse or a boon?
Let's discuss today. Welcome to Training Day. Still, many people are afraid of these three symbols. If you are one among them, just watch this video completely to understand what is lambda, why lambda, how lambda, and where lambda. So understand this very simply. Lambda expression is just a short way to write a small piece of code that does just one job. Think of it like giving a quick instructions without writing a full story. So look at this small scenario. Imagine that you want to tell someone add two numbers. In old Java style, you would create an interface, create a class, implement the method, create an object, and call the method. That's like too much of coding, isn't it? Okay, that's like writing a full letter just to say add 5 and 3. So too much of work. So the same thing can be done with a lambda expression in a short and smart way. Instead of writing a full class, you just say take A and B and add and give it a result. It sounds a little rude. That's what lambda is, very straightforward. So what we gain? We don't need to do unnecessary drama, like we don't need to create a lot of boilerplate code, like creating a class, implementing, create a method, right? So nothing is required. So less code, less problem, less debugging, so more productivity. So look at another real life example. Think of ordering a juice. The old way is like go to the shopkeeper, go to the shop and ask like this, dear shopkeeper, please prepare mango juice for me. So this is like without lambda. But the lambda is just very simple, mango juice please. Same meaning, fewer words. Okay, so take this example. I want to print a hello world or just a hello. So without lambda, you have to create an interface and create an anonymous class and implement this. See that? Lot of coding. And finally, you call say hello. So this is like without lambda. And the same thing can be done with a lambda in just one line of coding. See that? Interface on the left hand side and the parameter list and the lambda symbol and the implementation. So if the implementation doesn't have more lines, then you don't even need the curly braces. So less coding, less problem, less bugs, less maintenance, more productivity. Switch to lambda expression. Now let's go into a real banking example. So imagine that we want to check if the customer is premium customer or a regular customer. So what is the condition? If the balance is above 10,000, we'll decide that it's a premium customer. Else, we'll decide that it's a regular customer. Okay, so if you want to do that in a normal method version, you have to create a method, define a method, right? And then you write a business logic. But the same thing can be done in the lambda expression with just one simple line. Okay, amount, lambda, and the condition. So there's a parameter list, lambda symbol, and the implementation. That's it. So let me explain you lambda expression with just one example. So imagine that we have an interface called premium eligibility with just one method. It takes one parameter, balance amount, and returns true or false based on the eligibility. Okay, and now if you want to do that before lambda expression, all you have to do is you have to create a customer, you have to create a class, implement the interface, and override the method. See that? This is what I was saying, the boilerplate code. Okay, then you go to here, the main method, and you have to create an object and call the method, or you can use an anonymous class. Okay, right? Something like this. So like too much of coding. Okay, and if you want to do that same with a lambda expression, just see that just one line of code. The parameter list and the lambda symbol and the condition, and this returns a true or false. Now you call the condition, the method, and then whatever you want to do. Very simple, just one line. So next question is that when can we use lambda? Is it like can we use lambda everywhere for all the conditions, all the cases? No, there is a restriction. So use lambda only when there is one method in the interface, rather one abstract method in the interface, and such interface is called as a functional interface. Okay, right? You also would have heard about an interface without any method, that is a marker interface, and this is a functional interface. So that means you can define lambda expression only for functional interface. Okay, that means is it a limitation? No, it is focus. It is a designed decision for clarity. Lambda represents just a single action, a single rule, a single behavior. Each one has the responsibility that makes lambda clean. Okay, and look at it here. So before Java 8, we had interfaces. Interfaces were contracts, like a set of methods, and anonymous classes are bulky. But after Java 8, Java introduced a functional interface. Lambda is for more modeling behavior. So just think in the real world. Okay, if an interface has multiple behaviors like methods, it is modeling a thing like customer, account, etc. But Lambda is not for that purpose. So Lambda is not for modeling things. Lambda is for modeling behavior. A big conceptual difference. What do you mean by modeling a behavior? Just one thing. Okay, just take one action, take one responsibility and fulfill that. Okay, so the final clarification is here. It's not exactly one method. It's actually one abstract method. So that means you still can have default methods, static methods, and private methods starting from Java 9 onwards, apart from that one functional interface method. So far, we have seen the basics, the syntax, and a few simple examples. But real projects rarely look this clean. So the question is how this actually used in production code. Let's find out. In fact, many people say this during the training. The examples look very simple and straightforward. Do you agree this? Yes. But once they enter a real project, the code suddenly looks much more complex. So let's see how the code used in production using Lambda expression now. So example 1, let's take this piece of code and see that here I have added few product objects into an array list. Okay, and then here I have written a piece of code to iterate and print the names of all the products. This code looks simple, but there is a hidden mystery behind it. Let's uncover it. So this is actually syntactic sugar. Internally, Java converts it into code using an iterator. Yes. So the internal mechanism of this code is the Java converts this into an iterator. Okay, how? What actually Java does internally, okay, is from the array list, it calls the iterator method, and this gives an iterator object. Okay, iterator product object. Okay, like this, right? Then it also generates this code while iterator has next. So this also generates this code. Internally, this code is generated while iterator has next. Then product p equal to iterator dot next and system dot out dot println p dot get name. Okay, so these many lines of code is shrunk into just 2 lines. Okay, so in fact both will give the same output. So the next question is why this is converted into an iterator like this. Okay, so what makes Java to generate this code for this enhanced for loop? So this is very simple. Okay, so this loop works with anything that implements an interface called iterable. Okay, so in this example we have a list. Okay, so just control click on this to see the documentation of interface, to see the documentation of a list interface, and again that extends another interface. Control click, keep going, and finally see that. Okay, right, we reached a collection interface, that is a topmost interface in the collection framework, and you see that extends iterable. Then let's get into the iterable, and the iterable has an interface called iterator interface. So this is the reason that why Java has generated this code for this statement. It is very simple. See, Java doesn't generate the code randomly. So since indirectly the list implements iterable interface, okay, so it has generated this code. Let's see one more example. Let's see another way. Now let me remove all the code. Okay, so I'm just going to type another similar example, but this time I'm going to use for each method. Okay, so using for each with the Lambda. So first you take this array list, all products, the list, and put a dot and see that there is a method called for each. Okay, the for each, and the for each is a method, and the for each is a method in the list, and see the parameter, it expects a consumer implementation. So this expects an implementation of consumer interface. So what is a consumer interface in Java? A consumer interface is an interface that just consumes the elements. That's it. So look at this. The for each method accepts an implementation of consumer interface. Okay, so if you want to know what is consumer interface, just click on this and see that. So consumer interface is a functional interface in Java Okay, so it represents the operation that accepts a single input argument and returns no result. Okay, meaning that a consumer interface is a function interface that accepts only argument, the parameter, and returns nothing. Okay, and this is commonly used with the lambda expressions and the collections. Okay, so if you just want to go into the, if you want to see the consumer, then you can just type consumer here. Okay, consumer interface, and just see the documentation. Wow, this is fabulous. So this is how the consumer interface has been coded. So it is a functional interface. That means it has only one abstract method called accept. Okay, and this is a default method. Never mind. I already explained that the function interface can have any other non-abstract method inside the interface. Okay, so this has a method called accept. Okay, meaning that we need to provide the implementation for accept. So that's what exactly we are going to do here. Okay, so let's remove that. Okay, get inside this for each. Okay, so inside for each, we need to provide the implementation of consumer interface. Okay, so we need to provide an implementation of the consumer interface as a parameter for the for each method. Okay, so everything is like broken down into simple steps now. Good. Now let's see how to do that. Okay, so what you can do now, for each, so we have to write a lambda expression here. So we know the syntax of lambda expression, an argument and the lambda symbol and the business logic. So here the business logic is just printing the elements, that's it. So take a product from a list and then system.out.println p.get name. Okay, so simple, and see, this is going to give the same result, same output. Okay, so you can just run the application and see that you get the same output as above. Okay, so this is method number 2. Alright, so using for each with a lambda. So here you see the practical usage of lambda expression here. So all products, the list for each, the for each needs implementation of a functional interface which is a consumer. Okay, so let's see another example, another use case. Okay, so this time I'm not going to use I'm not going to print the product name, but I'm going to display the product with prices above 1000. Okay, like a filter, and see that how we can do step by step. Display the product name and okay, the product price, okay, with price above, let's say 1000. Okay, so now I don't want to implement this as a traditional for loop. Instead of that, I want to use a lambda expression here. So how can be done? So we have all products and use a for each and accept a product, write to a business logic. Okay, right now if the implementation of a lambda expression is more than one line, then we have to use a curly braces. So start with the curly braces and give the condition if p dot get price is above 1000, then system.out.println p dot get name and the price is p dot get price. So now let's run this. Wow, this is working. See that we just listed out all the products right above 1000. Okay, but to implement this, how many lines of code you have written? Only a few lines. Okay, using the lambda expression. So this is another example, another real use case in the real project. Okay, now let's see a little complex example. Okay, the scenario or the use case is a bank maintains a list of accounts and we want to print VIP customers, meaning that the balance is above 1 lakh. So we just consider them as VIP customers. And we want to apply service charges for low balances, like if the balance is below 5000, then we want to apply service charges, and then we want to sort accounts by balance. Okay, so now let us see how to implement these use cases simply using lambda expression by writing only fewer lines of coding. First, let's create an account class. So this is my account class. So every account has account ID, the account holder's name, and the balance. Just keep only few properties, and you feel free to add more properties. Okay, good. Now let's see the main banking logic using lambda expression. Okay, so let me go and create another main class, main bank app with a main method. Okay, right. Then first I have to create a few accounts. Okay, right. Let me just copy and paste the code to save time, fix the compilation error. I see that I have few accounts. Problem statement 1, use case 1. Okay, so printing all VIP customers if the balance is above 1 lakh. So how this can be done using lambda expression? First, take the accounts list accounts. Okay, right? Then you can use for each accounts at for each, right? And here to write a business logic. So now let's see the use case 1, printing all the VIP customers, meaning that the customers whose balance is above 1 lakh. Okay, so first what you do, take the array list, because the array list has all the customer details. Okay, then use for each. Okay, then pick up an account object from this array list and then write to a lambda. So if the balance of the account is above 1 lakh, see that this is a business logic. Okay, then what you can do, system.out.println. So system.out.println. Okay, a dot name and a dot balance. Okay, now let's run this and verify. Wow, this is excellent. And look at this. So Ravi and Arjun, they are the two customers whose balance is above 1 lakh. So they are VIP customers. Okay, but how many lines of coding we have written? Just few lines of coding with the lambda expression. Okay, good. So this is one. Let's go to the next use case. Use case number 2. Apply service charge. Okay, so apply the service charge. Okay, meaning that if the balance is below 5,000, I am going to deduct 100 rupees. Okay, if the account balance is below 5,000 rupees, then deduct 500 from this. Okay, 500 from the balance. Again, we can use for each. Okay, so accounts dot and for each we need a functional interface implementation, the consumer here. Okay, take an account and then if a dot balance is below 5,000, okay, right, and reduce deduct 500 rupees from this balance. So a dot balance equal to a dot balance minus 100. Okay, and this could be written using the getter function. Okay, right, it is not advisable to access the properties directly like this. So while implementing this, you can go to the account class and you can generate the required setters and getters. I have not done, but you can do that. Okay, so this is done. Okay, once it is done, let's see that whether it really worked. Okay, all right, so accounts for each and take account and system.out.println and a dot name and a dot balance. Okay, so maybe we can do one thing. This is before applying the service charge. Before applying the service charge, and this is after applying the service charge. Okay, all right, so system.out.println before applying the service charge, and this is after applying the service charge. Okay, let's see that whether it works. Okay, fabulous. See that. So before applying the service charge, 12,000, yeah. See, look at this, the second customer, Anita. Okay, so whose balance is below 5,000? Okay, all right, so what happens? It reduced 100 rupees. See that? So 3,000 becomes 2,900. And similarly, Kiran, no change because the balance is above 5,000. But for Meena, and see that it is 2,000, so it has become 1,900. So 1,900. So this is working. Okay, right? So just look at the amount of coding. Good. Now let us go to the third use case. Okay, so use case number 3. Right? I want to sort. So sort the accounts based on the balance. Okay, right, from ascending order, like in ascending order. Okay, so for that again you take accounts list, and this time you have to call the sort function. Okay, and sort is a method and it needs a implementation of a comparator interface. See that now this is not a consumer, this is now expecting an implementation of comparator interface. Okay, so the comparator has a compare method you need to implement. So now what we can do, take for comparison we need two objects. So now let us take account object 1, account object 2, because we have to compare. So now the lambda expression, the parameter, now the parameters of lambda expression is 2. Okay, right? Now the lambda expression has 2 parameters, account number 1 and account number 2. Account object 1 and account object 2, and then we just compare. So double dot compare. Okay, right? A1 account 1 balance and A2 account dot balance. Okay, right? So simple. Okay, so double dot compare account 1 dot balance comma account 2 dot balance, and let's return because it expects a return statement. Okay, so this is fine, right? So why it is expecting the return statement? Because we have given the curly braces. Okay, so in the lambda implementation, if you don't give the curly braces, then return is not required. See that it works now. Okay, right? It works now without curly braces. Okay, print. So print after. Okay, right? So print accounts after sorting. Okay, I just copy the same code here. If you want, you can also make a new method, but let's do this now. So print after sorting by balance. Okay, run this. Okay, so fabulous. See that now it is sorted based on the balance. So 1900 is the lowest amount, then 2900 and 75,000, 1,20,000 and 1,50,000. Okay, but how many lines of coding we have written? Just only one line. And where is a lambda? Here is a lambda. So what it does? So the sort method needs an implementation of the comparator interface. Okay, so we can write this, right? So if you just go to the comparator, let's click on this. Okay, Java, it will comparator. So just type comparator. Okay, click on this. Yeah, see that? So comparator is also a function interface. Okay, so meaning that, so this also has one abstract method, that is compare. Okay, so this is what exactly we have called here. So we have called here. Okay, good. So this is another example of how you can use lambda expression for these type of examples. So we have come to the end of this video. So what we have learned, in short, lambda expressions reduce boilerplate code, improve readability and make working with the collections much more powerful. And also, like in continuation with this, we also have another powerful technique called Stream API, which heavily uses the lambda expressions. So I'm planning to create another video on Stream API that is going to use lambda expression, so stay tuned. Okay, so coming back to the justification of the video title, is lambda a curse or a boon? It can feel like a curse at first. The syntax looks unusual, the code sometimes becomes very compact, and for beginners it can be a little hard to read and understand. But once you get comfortable with it, lambda expressions become a boon. So they reduce the boilerplate code, improve readability and make operations and collections for filtering, sorting and processing data much easier. Okay, so today it may look like a curse, but once you master it, lambda expressions are definitely a boon. If you are looking for similar tech videos, subscribe to my channel and encourage me to create more such videos. See you in the next video. Till then, tata, bye bye.